Today's daily LeetCode problem of the day is construct string with repeat limit number 2182. For this problem, we're given a string s and an integer called our repeat limit. We want to construct a new string called repeat limited string using the character of s such that no letter appears more than the repeat limit times in a row. We do not have to use all the characters from s, but we want to return the lexicographically largest repeated limited string. So, what does this mean? In order for a string to be the lexicographically larger, that means that the positions of the starting characters need to be greater from one string to the next. So here in example 1, the starting character is Z. In our original string, the starting character is C. Z is a larger character than C. Therefore, it is lexicographically larger. Because we have two Z's, we can make sure this string stays larger by putting the two Z's first and then letting C's come after it. Another thing we need to take into consideration while we're building our string is that we can only use characters that appear here in our new string. So, for example, just because there is a Z in the first string does not mean we can put three Z's in a row. We can only use the two Z's that appear there. So we're limited to two Z's. There are four C's that appear, so we're limited to using four C's. One A appears, so we're limited to using one A. So why do we have the option to not use all the characters from S? Well, let's say, for example, that we had four A's and only three C's. So we go C, 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 and then we're going to go four A's in a row. Well, our repeat limit is 3, so we can cut off that last A. It would not make sense for us to go two C's and then an A and then our last C, because it would no longer be the lexicographically larger, as another string could be C, 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 A, which is greater than if we had put C, C, A, C, for example. So taking that all into consideration, how are we going to approach this problem? It requires two main techniques. We're going to have a greedy approach to build the largest lexicographical string. We will always prioritize our highest frequency letters in a descending order, meaning going from Z to Y to W, so on and so forth. Then we will use a max heap or a priority queue to always pick the largest available character, like Z is greater than C. Here's our plan. We're going to count the frequency of each character using a hash map. So, one, we're going to count frequency using hash map. We are then going to add all unique to our max heap, and we'll store it in descending order. Then we are going to repeatedly take our largest character and append it up to a repeat limit times. So we are going to add chars to new string, and then ultimately we can return our new string. So let's go ahead and jump into this code. Step 1, count our frequency using a hash map. So let's initiate a map. It's going to store our characters and integers. The character is going to be the character we're thinking of, and the integer is going to be how many times it occurs. So this is a frequency map. It's a new hash map. And so to initiate this hash map, we're simply going to take for each character C in s.toChar array, making it simple to traverse. We're going to take each character C and put it into our map. So frequency.put C, and we're going to frequency.get or default C to 0 and add 1 for each time it occurs. And that's it for our frequency map. Next thing we're going to do is use a max heap to always pick our largest character. So we're going to initiate a priority queue that is going to store our characters. And this is our max heap, so we can label it that. And that's a new priority queue. Now, for our priority queue, we're going to have to initiate it to compare our characters in a way that's going to sort them from greatest to least. So, we're going to have our characters A and B. These are two example characters, and we're going to use a lambda function to define how they're going to be sorted. Our characters are going to be sorted by comparing the two characters backwards, kind of. So, we're going to call to character.compare B and A. So the reason I said it's backwards, kind of, is because we define our two characters we're labeling as A and B, and then we're going to use our lambda to compare them, character.compare, but we're going to put them into the comparator as B comma A. So we're going to sort them from greatest to least rather than from least to greatest. If we put it A comma B, it would be sorted from least to greatest. And that is it for the priority queue. Next thing we're going to do is just simply add each of our characters to the priority queue so we can go through them and add them to our result. So for each character C, in our frequency map now, and we're going to use our key set, so we only have to go through each character a single time. We're going to max heap dot offer each character. So each character should be added one time, and then they'll be sorted from greatest character to least character. Next, we are going to build our result using a greedy approach. So we'll label it greedy approach. And to do this, we're going to use a string builder. Just makes things easier and more efficient. And this is going to be our final string at the end. So we're going to label it result. And we're going to build the string using a greedy way. So we're going to have a while loop, and it's going to say while our max heap is not empty. So not max heap dot is empty. So while there's always a character left in the heap, we're going to continue to add characters to our result. So we're going to take the top character in the max heap. So character C is going to be equal to max heap dot poll. So whatever the greatest character is, and take an integer called count, and that's going to be our frequency dot get C. So this is going to be the character that we're looking at, A, B, C, D, E, and count is going to be how many times that appears in our initial string. Then we are going to append the character a result limit amount of times. So we're going to have an integer called use, and that's going to be the math dot minimum between count and our repeat limit. So the reason we're using this variable to store how many uses of the character we get is we do not want our count to go greater than the repeat limit amount of times. So if our count is 1 and the repeat limit is 4, we will only append that character one time. But if our repeat limit is 2 and our count is 4, we will only apply that character a repeat limit of times. So now that we have our use amount, we can say for each integer I is equal to 0, as long as I is less than our use amount, I will increase. And because it's a 0 indexed, we do not have to put less than or equal to. It will count up to but not equal to use, but it will be the same amount. We'll simply result.append our character. Next, since we just used a character, we want to reduce it once in our frequency, or reduce it however many uses in our frequency array, or frequency map. So we're going to say frequency.put our character, and we're going to take the count minus the use amount. So it's either going to be equal to 0, or there's going to be a little bit left over. Either way, we want to make sure that we do not go over the repeat limit. So it's going to be count minus use. If there's some left over, we will continue on with this character later on. If the character still has occurrences left, so if our frequency.get C is greater than 0 and our max heap is not empty, so there's another character that can take its spot, then we are going to simply pick our next largest character, put it a single time, and then go back to the character C because it's not empty yet. So char next C is going to be equal to the max heap dot poll, And we will results.append the next C, or our next character, and then we will reduce its frequency. So this is simply like if we only have 3, our repeat limit is 3, and we put Z, 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 but we have 4 total Z's, we need to insert a character before we can put another Z. So if our next character is C, we're going to take one of the C's and put it here, subtract 1 from its use, and then we can put our last Z, which is Z is equal to 1, put our last Z after that C, and then we can continue on with our C's after that. That is not an arrow. Anyways. So, after we append the new character, we want to reduce it once in our frequency map. So we're going to say frequency.put our next character, and then we're going to take our frequency.get of that next character and simply subtract 1 from it. And that will reduce the frequency as much as we need. And if our frequency.get next C is greater than 0 still, we will put it back into our heap. So max heap.offer our next C. This will allow us to ensure that the character gets popped out of the heap. We use it a single time, and then we put it back into the heap while maintaining however many uses are left. After that, we can simply max heap.offer our C back into the heap. So that way, when we go back up here to the beginning of the while loop again, we will repop that character as it is still containing a use count, and then we will use it again. And that's it. We can then simply return our result.toString. And that's it. So if we run this, so that passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.